So a lot of new videos and topics have been coming out lately about how a new LLM model has managed to hack its way out of a secure sandbox and gain access to the internet when it was not supposed to. And I've been seeing a lot of headlines that are a bit interesting and people talking about the topics all over the news, and I wanted to get myself in there and try to understand what was going on. And in this video we're going to talk about Claude Mythos, the LLM that everyone seems to be talking about, that is apparently too dangerous to be used for the public. So in this video, we're going to talk about the incident of how it was able to hack its way out of a secure sandbox. We're going to go over some of the information in the scorecard that Anthropic released. We're going to try to understand what is going on there and why everyone is talking about it. So let's jump right in. So let's start at the very beginning. What is this new LLM model? This is a new preview model by Anthropic that is supposed to be in their chain of new LLM models that they're developing. And this model has been proven to be really good across the board, beating up most of their previous LLM models that they generated, but it was specifically good at cybersecurity tasks. Now, the reason why this particular model is getting a lot of, let's say, media nowadays is because of one specific incident. Apparently, Anthropic placed this model in a secure sandbox and it managed to escape and hack its way out of it. So it managed to find some vulnerabilities into the sandbox it was built in. It managed to escape and it managed to send an email to the researcher, which I find very funny, who only found out about this by receiving an email from the AI itself telling it that it went out while the researcher was eating a sandwich in a park. Now, this LLM didn't just manage to escape confinement and basically get out of the sandbox that it was put in, it also managed to gain access to the internet and publish all of the vulnerabilities that it found on the internet. And this is what everyone has been talking about in the past few days. Basically, the fact that this AI managed to escape out of a secure sandbox, gain access to the internet when it wasn't supposed to. The fact that the researcher only found out as he was eating lunch. But there are a few things that the headlines don't tell you right away. Let's start with talking about how people found about this in the first place. Now, this is actually publicly available information. It's part of the Claude system card that Anthropic team and Apollo Research usually get out every time they preview a new model. This is part of extensive research and extensive testings that they do to almost all of their LLMs. You can remember that this is also something that we talked about in one of the previous videos when we were talking about AIs being able to know when they're being tested, and also a lot of other topics when people talk about LLMs lying or doing deceit or blackmail. It's always part of some testing that is provided in one of these documents. Now, the main goal of these tests is to usually see how the model reacts after a series of circumstances and a lot of different tests to just get an idea on how good this model can be. And then they can tell if this model is good for use for the public or if it needs more testing or if it's not ready to go out yet. Now, let's focus on the incident we started with. The model was actually given the prompt. It was given a simulated user prompt to do what it did. It was asked to try to escape out of the secure sandbox and email the researcher about it. So this is the task that it was given, and I like the idea that the researcher wrote that prompt in, just went out, and then recently got the email notification that it was successful. But the part that was not part of the prompt was the fact that the AI didn't just escape, but rather publicly talked about the vulnerabilities that it found. This was not part of the prompts, but rather part of the model's inherent need or want to publicly talk about the stuff that it found. This is more about the agentic behavior of the AI that they also seem to want to find, and let's say this is why there is more random testing or like different types of testings that they do to be able to find these scenarios that will not be found by typical basic tests. Now, what I couldn't find personally if whether these vulnerabilities that the model found was stuff about the system kernel that it was put in, so whether or not the vulnerabilities it found was real system vulnerabilities, or whether some of these vulnerabilities were added by the researchers themselves. So basically, they knew that some of these mistakes, some of these, let's say, vulnerabilities can be exploited for someone to gain higher privileges, and they wanted to see if the model will be able to find them, or if it was actually placed in a secure environment where it was not supposed to be able to get out, but then they wanted to see if it would be able to hack its way out of it by finding vulnerabilities they didn't know about. My assumption is that it could be both of them. It could also just be a more simulated environment with built-in handmade vulnerabilities in there. But this I couldn't find myself. What's also really important to talk about here is that the model was actually being put in a separate test environment. So the system that the model was able to escape out of and, let's say, gain control of wasn't the actual system that the model was put on, not the actual server that hosts the weights in the model, but a different virtual machine or a different system that was simulated for this particular task. This is to say that the actual model weights and actual stuff that comprise what Claude actually is stayed protected under some really good security measures. Now, why are these tests relevant, or why should we care about them, right? Now, these tests show what if you, as a person using LLMs in your own systems or servers as a chatbot that has access to users and users can send prompts to, this shows what this model can do if given, let's say, a very bad prompt that would cause it to do stuff that it was not supposed to. And this is something that most people who use these systems, whether a company or a different person working on their own project, would need to know about the LLMs that they're providing. This part of all of the assessments that they do is very important for anyone who wants to work with LLM systems and anyone who wants to build, let's say, bigger projects that rely heavily on LLMs. Knowing that these LLMs do have risk and do have some security issues that they can run into is good for you to know what you need to know to build some guardrails around that, or to make sure how you can prevent it from happening to your systems or to your own personal machines. Following on that note, this incident was not the only thing that happened with the new Claude model. They actually found another bunch of rare instances that showed that the model was doing a lot of stuff it was not supposed to. For example, they showed that the model had rare instances where it would do public data transfer when it wasn't supposed to. Basically, the LLMs would create or use services that would create web pages in order to publicly post information that would be confidential or should not be published, just to share it with the internal employees. Another funny thing that I found that was very interesting to me was that we talked about how we can evaluate LLMs. And one of the most used cases for evaluating LLMs is LLMs as a judge, where they use an LLM to evaluate another LLM. And they found that with this specific preview, the model and some of the previous versions were able to figure out that they were being judged by an LLM, so they were prompt injecting the judge LLM in order to get their submissions to be successful. They also noted instances that are very rare that they called clearly dishonest behavior, where if they would give Claude some code and ask it to analyze it for risks and vulnerabilities, instead of analyzing it and finding new or vulnerabilities that are in the code, it would edit this code, add its own vulnerabilities, and then present these vulnerabilities as ones that have existed before it even started. They also showed instances where the model was trying to break free of restrictions in order to satisfy a certain goal, which showed that its agentic behavior was always in the sense of trying to not follow the guardrails, but rather reduce the amount of restrictions and guardrails that it has in order to finish that task. These are all rare instances, but they noted all of them, which tells you that some testing is needed in order for us to figure out when we can trigger these behaviors. Now, stripping away the headline language and the hype that people talk about this without making it seem that it's something that it isn't, it shows more about the capability of the model, but also the hardness of evaluating LLMs when it comes to the agentic behaviors that they possess. When we design LLM models, we design them with the intent of them being agentic agents that are able to do stuff on their own, meaning that we give them these tasks and we hope that they will follow the guardrails that we put into it in order to find a successful solution. But the way we design models in general is always about how do we find the solution fast and how do we find it more often. This is something that we talk about whenever we talk about reinforcement learning, for example, where we talk about models always have the notion of exploration and exploitation, where if they find something that they can exploit, they usually go for that to gain more reward. But when we talk about this model and why it was not sent to the public, we also have to talk about it in the bigger picture and not just within this incident. You see, this model is part of what we call Project Glasswing, a new initiative by Anthropic that would give this model to a lot of different companies that I'm going to add on the screen, I'm not going to say, in order to make sure that the people who are working on critical systems are able to gain access to this model in order to make their systems more secure. Now, why is this given to big companies and not just to the public? For two reasons. One, Anthropic seems to think that this model is very capable of doing, let's say, automated hacking, but this is not the only models that can do that. Actually, a lot of models that have been trained or done by other people in order to do this agentic hacking do exist. The second problem is when this model is able to look at something and find these vulnerabilities, it's smarter to give access to people who can fix these vulnerabilities, understand how to build a more defensive system before you roll out this system publicly and let everyone be able to access all the vulnerabilities of all of the other systems before they get a chance to fix it. This model was able to find vulnerabilities in systems that were before deemed secure, so vulnerabilities that we didn't know they already existed, and they were able to chain some of these vulnerabilities together to find exploits to gain access to the system. And this is the whole reason why this project Glasswing has existed, because now you can give access to this information to the people who can actually fix it and the people who can actually work on building defensive systems so that you don't get yourself hacked by an AI. Now, to end this, it will be my usual ending where I ask you to look at the actual papers and documentation provided by the researchers and do your own research before just listening to the headlines and hearing what the hype is saying. But I also want to talk about how, while this can sound scary, I don't find the tool scary. I don't feel that the AI is scary as much as I feel the people who use it are the ones we should be scared of. You should take that with a grain of salt, but a tool is a tool. It can be used to enhance people based on what they ask of it to do. What all of these tests are showing is that when not giving enough guardrails, when prompt injected in order to do some malicious intent, most of them will comply and try to do exactly what you asked of it. And this is why, as someone who's building your own system, you should be able to figure out how to guardrail your systems in order for that to not happen. But you should also know that the systems you're using that contain these systems also have a risk that you should be able to deal with. And this all exists not because AI is a bad system, but because the people who attack these systems are doing bad things. I don't think that this model is something that we did not expect to find eventually. They were training this model specifically to be able to do cyber tasks, and if it's able to understand vulnerabilities and fix them, it's also able to find vulnerabilities and exploit them. And the way LLM research and AI research in general is going, there are going to be better models and there's going to be more risk that comes with these bigger models. So documents like these are very important for people to find out about the risk, being able to actually fix it. But we should be able to look at them behind the hype. We should be able to look at them as what they are, understand the system test that was done without looking at it as AI is evil, AI is taking over the world, and just get scared about it. And with that, this is all the talking I'm going to do about this model in this video. I hope this made it easier to understand what happened and where exactly it comes from without being too focused on the hype language. I hope we're able to look at these documents and understand the bigger picture of things rather than the one thing that people seem to talk about in all of their videos. And I hope it was useful. So as always, stay curious, do your research, and I'll see you in my next video.